Hello everyone, my name is Ammar Bello, the co-author of this research paper. And on behalf of the author Shamsuddin Yusuf Omar and myself, I'll be presenting our research titled Exploring the Potential of Agro-Waste in the Development of Sustainable, Lightweight and Thermally Insulating Building Materials. The construction industry faces two major challenges: the depletion of natural resources and the accumulation of agricultural waste. By 2050, the global population will require enormous amounts of housing materials, but resources like cement, steel, and sand are becoming scarce and unsustainable. This study explores the use of agro-waste, such as groundnut shell ash, as a sustainable alternative to traditional materials, focusing on cost reduction, energy savings, and improved thermal insulation. Let's dive in. As the global population continues to grow, the demand for housing and infrastructure is intensifying. By 2050, the population is expected to exceed 9.7 billion people. Meanwhile, agricultural waste, which is often discarded or burned, poses significant environmental challenges. For instance, in countries like India, over 600 million tons of agro-waste are produced each year. These residues not only contribute to environmental degradation, but also represent untapped potential for creating sustainable building materials. Our research focuses on leveraging agro-waste as an alternative resource for building materials, specifically ensuring these materials meet ASTM standards for construction, quality, and performance. The primary objective of this research are fourfold. First, we wanted to understand the physical, chemical, and thermal properties of agro-waste materials. Specifically, we focused on groundnut shell ash and its potential as a substitute for cement and aggregates. Second, we wanted to evaluate the environmental and economic benefits of using agro-waste in construction, particularly the reduction in carbon footprint. Lastly, this work aims to promote the use of sustainable materials in the building sector and reduce dependence on traditional conventional resources like cement, sand, and even more. Our methodology involved several key steps. First, we conducted a comprehensive literature review, which examined various types of agro-waste, including granite ash shell, coconut shells, and oil palm shells. We focused on their chemical composition and potential for use in construction materials. Second, we performed a series of laboratory tests to evaluate the physical and chemical properties of these materials, including water absorption, specific gravity, and compressive strength. We also tested the thermal properties for potential use in insulation, which is of course very important as well. Finally, we conducted a life cycle assessment to compare the environmental impact of agro-waste materials against traditional building materials like cement and sand. One of the key findings of our research, which I want to highlight, was the potential of groundnut shell ash as a building material. Chemically, it contains a high percentage of silica, which makes it an effective pozzolanic material, meaning it can react with lime or cement to form a cementitious product, or we could say sticky material if we want to be non-professional. Additionally, groundnut shell ash contains minerals like potassium, calcium, and iron. In terms of mechanical properties, we found that it has excellent thermal insulation properties, making it a potential alternative to other insulation materials. The material is also quite lightweight, which is very good for earthquake regions, which can help reduce the overall weight of the structure as well. Our tests also showed that ground shell ash can replace up to 30% of cement without sacrificing compressive strength. This is a pie chart view of the chemical composition of ground shell ash. As we can see, silica with about 40% silica, alumina 15%, iron oxide 10%, and others at 35%. This bar chart shows us three different agro-waste materials and the specific gravity and water absorption due to each other. This is also another graphic description of the CO2 emissions of various building materials, basically comparing cement with agro-waste materials, and you could see that cement has a much higher CO2 emission compared to ground shell ash, rice husk ash, and groundnut shell ash has the lowest, which is why it was the focus of our research. All right. The environmental benefits are also significant, as we said. By substituting agro-waste for traditional building materials, we can reduce the carbon footprint for most of the projects out there in construction. This helps to reduce CO2 emissions associated with cement production and also mitigate the environmental impact of agro-waste disposal, which is often burned or sent to landfills. On the economic side, agro-waste based materials are cheaper to produce, providing a cost-effective alternative to normal building materials. Also, I would like to say that this can create new opportunities for farmers and rural communities by turning waste into a valuable resource, stimulating local economies and creating wealth. And of course, despite the promising potential, there are some challenges to overcome. One major issue is the variability in the quality of agro-waste materials. Factors such as the source of the agro-waste, seasonality, and how it's processed can lead to inconsistent material properties. Additionally, while agro-waste materials are lightweight, this can limit their application in load-bearing structures unless they are properly reinforced. There is also a lack of established industry standards for the use of agro-waste in construction, as they are pretty new discoveries. And this represents or presents a challenge for large-scale adoption. And finally, agro-waste needs advanced pre-processing techniques to ensure consistent quality and improve its properties for building material use. This is also a graphical view of the agro-waste, challenges in building materials: inconsistency in quality, structural limitations, and the severity in the y-axis. These materials, that is agro-waste, have several exciting applications in construction. For example, groundnut shell ash can replace part of the cement and fine aggregates to create lightweight concrete, which is particularly useful for reducing the overall weight of buildings, especially in earthquake regions like Turkey and some parts of Syria and places in the US like California and what have you. Another key application is in thermal insulation. Agro-waste materials, especially those with good insulation properties like ground shell ash, can be used to create lightweight insulating bricks and panels. Additionally, agro-waste can be used in combination with natural fibers like coconut coir and sisal to create stronger, more durable materials and even long-lasting materials for construction. Looking ahead, I would say there are several areas for future research. First, there is a need for standardized guidelines and regulations for the use of agro-waste in construction to ensure it's safe and reliable to use. Further research is needed also into hybrid materials that combine agro-waste with traditional construction materials like cement and sand to enhance their properties. I would say large-scale trials and pilot projects will be essential to test the real-world performance of these materials. And finally, collaboration between researchers, industry stakeholders, and policymakers will be crucial for promoting the widespread adoption of sustainable construction materials or practices. In conclusion, agro-waste represents a promising solution to the challenges facing the industry today. It offers a sustainable, cost-effective alternative to traditional materials while providing environmental and economic benefits. However, there is still much to be done, and further research, standardization, and collaboration are needed to ensure that these materials can be used safely and effectively on a large scale. Thank you for your attention, and I'm happy for further contributions.